Okay, today's paper is May June 2021 S1 variant 1. Let's start. The first question says a bag contains 12 marbles, each of a different size. 8 of the marbles are red and 4 of the marbles are blue. How many different selection of 5 marbles that contain at least 4 marbles of the same color? Contain at least 4 marbles of the same color. So there could be, since this is a question on combinations, let's first write down uh, the data that we have. There are 8 red and 4 blue. I'm making a selection of 5 marbles. So I can have different cases. I can have 4 red and 1 blue. Then I can have 5 red and 0 blue. Then I can also have 4 blue and 1 red. So I make a total of 3 cases. I get 8C4 into 4C1 plus 8C5 into 4C0 plus 8C1 into 4C4. This gives me 280, 56, and 8. 280 plus 56 plus 8 gives me total 344. Okay, that's the first question. The second question says the company produces a particular type of metal rod. The lengths of the rods are normally distributed. So this is a question on normal distribution with mean 25.2 and standard deviation 0.4. A random sample of 500 rods is chosen. How many rods in this sample would you expect? So I'm asking you to find an expectation to have a length that is within zero point 0.5 centimeters of the mean. So the probability then is 25.2 minus 0.5 and 25.2 plus 0.5. If I standardize this, convert it into a z value, I get 25.2 minus 0.5 minus 25.2 divided by 0.4. 25.2 plus 0.5 minus 25.2 over 0.4. I get 1.25 and 1.25. This becomes phi of 1.25 minus phi of minus 1.25. This becomes phi of 1.25 minus 1 minus phi of 1.25. So it's phi of 1.25 minus 1 plus phi of 1.25. Looking at the normal distribution table, 1.25, 8944. It's 0.7888. Okay, then the question is about finding the expectation. So I multiply this probability with 500. That's important because that is the only way to get all the marks in the question. 394.4. Okay. Uh, since it says, what does the question say? says how many rods in this sample. So you can either say 394 or 395. That's up to you. Where's 394 because rounding down would give me 394. Okay. Okay. This is a question on permutations. It says how many different arrangements are there of the 8 letters in the word released. So let's count how many of these are identical letters. 8 factorial divided by 3 factorial. Since there are threes, I get 6720. That is the correct answer. It says how many of the different arrangements are there of the 8 letters in the word released in which the word letters LED appear together in that order. So LED appeared together in that order. So I'm left with how many letters? There were a total of 8 letters. So I'm left with 5 more letters. These contain 2 E's. Okay. The box serves as 1 dash. So I'm going to say that this becomes a total of 6 dashes. So 6 factorial. I don't shuffle inside the box because the question prevents me from doing that in that order. Okay. I just divide by 2 factorial and that gives me 360. Okay. Then it says an arrangement of the 8 letters in the word release is chosen at random. Find the probability that the letters A and D are not together. So one of these arrangements that you described in the first part out of 6720. So I know that the denominator has to be 6720. I want to find the probability that A and D are not together. There are multiple ways of doing it. I could find the probability of together and then subtract it from one. And that I think is the easy way to do it. A and D inside, and there are 6 letters outside. So I get a total of 7 factorial. Then inside the box gives me 2 factorial. There are 3 E's that are repeated, so 3 factorial. So that is the probability of together. If I subtract it from 1, I'm going to get not together. What does that give me? 3/4. Hopefully that's the correct answer. 3/4. There are other ways of doing this as well, and it's up to you how you want to do it. Question number 4. It says to gain a place at a science college, students first have to pass a written test and then a practical test. Each student is allowed a maximum of 2 attempts at the written test. A student is only allowed a second attempt if they fail the first attempt. Okay. First have to pass a written test and then a practical test. So there's a sequence of events. Each student is allowed a maximum of 2 attempts at the written test. A student is only allowed a second attempt if they fail the first attempt. No student is allowed more than 1 attempt at the practical test. If a student fails both attempts at the written, they cannot attempt the practical test. The probability that a student will pass the written test at the first attempt is 0.8. So I draw the written test first. This is pass, this is fail. The probability is 0.8 and 0.2. If I fail the first written test, I'm given another written test. and the probability that they will pass in the second attempt is 0.6 and 0.4. These are all written tests. I'm just going to write written, 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 because it's going to get confusing from here. Then it says that if the student that student will pass the practical test. So from here, what continues is the practical test. So pass the practical test, fail the practical test, pass the practical test, and fail the practical test. The probabilities are 0.3, 0.7, 0.3, 0.7. Now, I always tell my students to first write down the outcomes so that the next parts are easy then. PW and PP, PW and FP, FW, PW, PP. FW, PW, FP, and FW, FW. Okay, there's a tree diagram. Let's see what it says. It says that a randomly chosen student will succeed in gaining a place at the college. So when you pass all the tests, only then you gain a place at the college. So this one, that's it. So I'm going to say that this is zero 0.8 into 0.3 plus zero 0.2 into zero 0.6 into 0.3. Point 0.276. Okay, that's the final answer. This next part says find the probability that a randomly chosen student passes the written test at the first attempt, given that the student succeeds in gaining a place at the college. So, given successful, and it's the written test at the first attempt. So, there must be a PW at the start. So, this will have the probability of whatever I calculated in the denominator, 0.276. And one of the branches that I had in the numerator, had in the calculations, will appear in the numerator. So, this one that has passing in the first attempt, zero 0.8 into zero 0.3. So, I get 20/23. Okay, let's check our answers. 0.276 and 20/23. Okay, then this next question is about drawing a histogram. It says the time taken by 200 players to solve a computer puzzle are summarized in the following table. Draw a histogram to represent this information. Whenever you are drawing a histogram or any other thing, the first thing that you have to notice is if these classes are connected. They are connected. In order to draw a histogram, you calculate something called the frequency density. The frequency density is frequency divided by the class width. So I'm going to say class width. Class width is upper boundary minus lower boundary. So I get 10, 10, 20, 20, and 40. Frequency density is frequency divided by the class width. So frequency divided by the class gives me 1.6, 5.4. 78 divided by 20 is 3.9. 32 divided by 20 is 1.6. and 40 divided by 20 is 2. Now, drawing these on a histogram, I have this much space. So I'm going to draw my axis. My horizontal axis goes from 0 to 100. So I'm going to label 0, 20, 40, 60, 80, and 100. This is the data and time. My vertical axis goes up to 5.4. So I'm going to say 1, 2, 3, 4, 5, 6. So first bar is from 0 to 10. It's a bar for 1.6. So I'm just going to write 1.6. Then the next bar goes from 10 to 20 and it has a height of 5.4. Then from 20 to 40, it has a height of 3.9. And then 40 to 60, I have a height of 1.6. Okay, a bit of shading inside. Okay. Although this shading looks really weird, so let's just get rid of it. Okay, then it says calculate the mean time taken by these 100 players. So the formula for mean is sum of fx over sum of f. I'm going to draw the table again for myself since x is something that I should be consciously calculating. X is the midpoint of each class. So the first class is from 0 to 10, so the midpoint is 5. Okay. The next class is from 10 to 20, so the midpoint is 15. The next class is from 20 to 40, so the midpoint is 30. After that, the class is from 40 to 60, so the midpoint is 50. Then the next class is from 60 to 100, so the mean is 80. Then I have F 16, 54, 78, 32, and 20. 16, 58, 54, 78, 54, 78, 32, and 20. 32 and 20. So I'm going to say that sum of fx over sum of f becomes what? It's 5 into 16 plus 15 into 54 plus 30 into 78 plus 15 into 32 plus 80 into 20 over the sum of f, which is 200. It's given right at the start of the question. I'm going to put everything on a calculator. Make sure that you don't make a typing mistake because that can cost you a lot. I get 32.15, which is approximately not necessary to round this off to three significant figures because this answer is exact. I've done some silly mistake in drawing the histogram. This should be 0.5. I lose a mark there because of a silly mistake. Okay, going back. That's the correct histogram there. I hope I've drawn all the other ones correct. Should be labeled frequency density. Okay. The mean is correct. Find the greatest possible value of the interquartile range of these times. Now, this is something that you should be careful about when you're calculating the interquartile range. Now, if you wanted an exact value for the interquartile range, you would need the cumulative frequency graph. But since I don't have that, and the interquartile range is the distance between the lower quartile and the upper quartile, what I'm going to do is I'm going to try to estimate the lower quartile and upper quartile. I'm going to say that where does the 50th observation lie? The 50th observation lies 16. Let's draw the cumulative frequency. And this becomes 70. So this is the quartile for the low, this is the class for the lower quartile. Then for the upper quartile, I need 3/4 of 200. That is 1/50th. Okay, so that one is the upper quartile. If I want the greatest possible range between these two, what I need to do is select this value and this value. That is going to give me the greatest possible distance between the two. So I'm going to say that the greatest interquartile range is 60 minus 10, which is 50. Okay. Question number 6. Question number 6 says in Questa, 60% of the adults travel to work by car. A random sample of 12 adults from Questa is taken. Find the probability that the number who travel to work by car is less than 10. So this is a question from binomial distribution because I'm giving you a fixed number of trials and I'm giving you 0.6 as a probability. If I'm asking you less than 10, so you need to calculate 0, 1, 2 up till 9. Instead, what you can do is you can do 1 minus probability of 10, 11, and 12. Writing down the probability is 1 minus 12C10, 0.4 power 12 minus 10, 0.6 power 10, 12C11, 0.4 power 12 minus 11, 0.6 power 11, 12C12, 0.4 power 12 minus 12, 0.6 power. I'm using my calculator to do this calculation all together. I'm not writing all the calculations down. You can also do that on your calculator. Get 0.9166. This is 0.917. Yes, that's the correct answer. Then it says a random sample of 150 adults. So this is suddenly grown into a large value for n. Since it says use in approximation, that is a hint that you need to use the normal approximation to the binomial distribution is less than 81. The first thing that you should do is do a continuity correction and say that is going to get corrected to 80.5. In order to calculate mu, you do NP, which is 115 to zero point 0.6. Traveling by car is 0.6. Yes, 115 to zero point 0.6 gives me 90. Sigma square is NPQ. So 150.6.4 gives me 36. So I get Z space on the next page as well. Okay, 1.583, 9433. 0.0567. Yes, that's the correct answer. Justify the use of your approximation. Whenever you ask for a justification, you need to calculate two expressions, NP and NQ. So this was 115 to zero point 0.6, which was 90, and NQ is 115 to zero point 0.4, which is 60. Both are greater than 5. So yeah, so this is a, so therefore use a normal. If these two conditions are not met, you cannot use a normal distribution for this question. Okay, the last question on this exam, this says Sharma knows that she has 3 tins of carrots, 2 tins of peas, and 2 tins of sweet corn in her cupboard. All the tins are the same shape and size, but the labels have all been removed. So Sharma does not know what each tin contains. Sharma wants carrots for her meals, and she starts opening tins one at a time, chosen randomly, until she opens a tin of carrots. So she stops when she opens a tins of carrots. The random variable x is the number of tins that she needs to open. Show that probability of x equals to 3. So probability of x equals to 3 means that she opens a can of not carrots, not carrots, and then carrots. So what is the probability of not carrots? It's 4 out of 7, 3 out of 6, and then 3 out of 5, in that order. They have to be in this order because I stop when I get a tin of carrots. So that's 6 over 35. It says draw up the probability distribution table for x. Now, interestingly, x is the number of tins that she needs to open till she gets a carrot. If she is very lucky, she's going to get a tin of carrots on the first attempt. If not, the second attempt. If not, maybe the third attempt. That's what I just calculated. So I'm going to write 6 over 35 here. It's also possible that it takes 4 attempts. But she's absolutely sure that when she opens the fifth can, even if she was unsuccessful on the first four, then she's going to be successful on the fifth one because she would have exhausted all the other cans. So probability of 1 is simply probability of carrot, which is 4 over 3 over 7. Then the probability of 2 is probability of carrot not, and then carrot. So 4 out of 7, 3 out of 6, because there are 3 carrots. That gives me 2 out of 7, I think. 2 out of 7. Probability of 3 is already done. So let's do probability of 4. So carrot not, carrot not, carrot not, and then carrot. 4 out of 7, 3 out of 6, 2 out of 5, and then 3 out of 4. What does that give me? I think 4 cancels out with 4, 6 cancels out with 6, so that's 3 over 35. For probability of 5, either you could subtract all of this from 1, or say this. It's 1 over 35. I think that's the correct answer. Let's check. Yes, all those probabilities are correct. Mine are reduced. That's fine. Then it says variance of x. So let's just copy this table so that it's easier to write. For variance of x, I will also need the expectation of x. So first the expectation. Okay. Then for the variance, that is what I have. Okay, that's the correct answer. That is the end of this exam. I'm going to solve the next exam in the next class. Okay, that is it for today.